This is Mangilal Agarwal from Lousiana Tech University. I am a research scientist at the Institute for Micromanufacturing, one of the research center at the university.
Okay. And you were working on paper batteries.
Yeah, like this project we started 2 years ago when we thought, okay, let's do something. Let's use nanotechnology in pulp and paper and try to see what we can come out with some products which are important in real life. We take this conductive polymers or carbon nanotubes and coat nano layers of those materials on the wood fiber and then use that wood fiber to make paper.
So why paper? What's intriguing about paper?
Biodegradable is the first issue, and second one is lighter in weight. It's available vast, so the paper can now pass the electricity. Now using that, what we are trying to do here, I'll show you. We used carbon nanotubes to coat on this wood fiber, and we use layer by layer nano assembly. So what we do is we use positive layer of one material and negative layer of one material. So positive, negative, positive, negative. So you can construct the nano layer, and it was put on the wood fiber. And so we made these paper samples here. This one is wood fibers coated with carbon nanotube, and all the wood fibers in this sheet are coated with that nanotubes. But when you come, we can change the concentration, virgin fibers versus coated fibers, and you can have different...
It gives you different voltages?
Yeah, different voltages, different resistance. So then using this technique, what we can do is we can make paper-based batteries, because we can put layers of these papers as a capacitor or as a battery. And like carbon nanotubes are mostly now, they are famous for being used in batteries. And
do you see consumer applications? I mean, is this something we could, a couple of years buy a paper-based AA battery to put on our electronic equipment?
Yeah, that's what I'm planning to do, and hopefully I have this idea, but always there are plus and minuses. But hopefully, with the evolving technology, with using nanotechnology and previous knowledge done by a lot of Nobel laureates, and so we can.
So advantages are paper's abundant,
yeah,
and it's relatively inexpensive.
Yeah.
How much charge does it hold, like in terms of density? If you were to make a AA battery, paper battery, would it hold as much as your typical Duracell today, or what?
Yeah, we are this will be my first experiment. Like I made capacitor, which is way higher, the same area of capacitance from organic material or from paper-based material. It's almost 10 times higher. It can store charge up to 10 times higher than what a normal capacitor can store.
So the big idea is conductive paper. How can you use it for all these different things?
Yeah. Okay. So that's what we started first, like making conductive paper, and then from there we wanted to make transistors, and we also worked with making this biosensor using conductive paper.
And what does it sense?
First prototype we made was glucose sensor. So it has this conductive layer, and then you can put enzymes on that paper, and then suppose people don't want to pick their fingers, what they can do is just spit on it or put it as a patch, and a little electrode can define, okay, what is the glucose in the fluid body.
So how long do you think it takes to get to a product? Like, how long do you think it'll be before these types of things you talked about would,
We are on the initial stage right now. Probably in a couple of years we'll be able to give our first prototypes, and we have already filed the patent on this application, and plus the technology. So maybe I think to come to a commercial stage it may take 5 to 6 years. Hopefully after 2 years when we have our first prototype.
Okay, thanks so much.
Thank you.
All right, that's great.